My name is Chris Rotz, and I will be chairing the following two sessions, as well as another one later. I'm also a sociologist and currently junior researcher and PhD candidate at the University of Basel. So I don't want to lose more time, so let's just start with this session on spatial planning and transportation challenges. We will have two presentations with a subsequent Q&A followed by three other presentations and the Q&A. I would kindly remind the speakers about their 10-minute time limit for their presentations. I will try to raise my hand 1 minute before your time is over and hope that I will not to be forced to interrupt you after. So the first presentation is by Wanming Wei from the National Taipei University with a title, A Study of Utilizing Big Data to Construct Sustainable Cities Transportation Planning and Design Evaluation Model. So Wanming Wei, the floor is yours.
Okay, thank you for the introduction by Christoph, our chair. Okay, my name is Wanming Wei, and I'm from National Taipei University in Taiwan. So the topic of my presentation today is going to be a study of utilizing the big data to construct the sustainable cities planning and design evaluation model. And the primary objective of this research is to conduct a study which is based on the concept of urban sustainability and smart city. And the second objective of this research is to integrate the two concepts as smart sustainable city as a constructing a related evaluation model. And the third objective of this research is focused on sustainability and smart city strategies and utilizing a decision model via the big data and the dynamic network process. And finally, we hope to validate this approach by an empirical example in Taipei City. And the research background will, My presentation outline will include the research background. And for the research design, which includes the fuzzy Delphi method, the big data collection and the data mining analysis approach. And finally, the dynamic AMP approach will be utilized. And before the discussion and the concluding remarks, an empirical example will be introduced. And for the research background, first of all, the EU viewed the smart city concept, which can support the idea of environmental sustainability and its main aim through the deployment of innovative technologies. And then we hope to integrate the technologies in terms of the ICT to promote our quality of living. And then we also hope to promote the big data for the urban planning in Taiwan. The satisfactory strategies must be formulated on the basis of the dynamic of future trends. And furthermore, the SETI's dynamic network process in conjunction with the data mining technology will be used to analyze the big data to develop a prediction tool. And this is the two main concepts for this whole assessment model. One is the sustainability focused on the environment and the society. And the other one is the smart city, puts emphasis on the economic and social indicators, which is very essential. And I'd like to introduce, there are three important criteria for our proposed assessment framework. The first one is the framework which can measure the smartness. So the ICT such as the big data, the IoT are chosen. And then the analytical tools such as the AMP fuzzy Delphi method are utilized. And finally, we should cover several areas of city functions, not only the transportation or energy, but the vulnerability and the resilience are also be considered. So this is the whole framework. So based on the future city concept, it includes the sustainable, the smart, and the creative cities components. So followed by the framework we proposed, so the research design will be followed as the following. So first of all, we propose the strategies. Under the strategies, we can collect the data we need for the relevant indicators. And then we utilize the time series and the AMP methods to handle all this data. And then we conduct an expert questionnaire to get what we need. And finally, we can propose the relevant strategies. And these are all the steps we utilized for our research design, which includes the assessment in indicators and the method we utilized, including the fuzzy Delphi and the AMP. And finally, the sustainable strategies will be proposed for our Taipei City. And there are two main categories under the smart sustainable city. One is for the urban sustainability, and the other one is for the smartness. And you can see all the different aspects are considered, including the environment, society, economic, and governance. And then we utilize the fuzzy Delphi method, which can help us to screen and find the most important indicators. For example, first of all, we proposed some important index or indicators from the different viewpoint of environment, economy, and the society. And by utilizing the fuzzy Delphi method, we can screen and select the most important indicators that everybody cares. And followed by the AMP approach. The AMP approach can help us to determine and to find the individual weights for each of the indicators we considered and we cared. So by utilizing the AMP approach, we can find the different metrics or vectors for each of the weights of the criteria or indicators. And in order to validate or evaluate our proposed model, an empirical study was proposed. So in order to illustrate our developed decision procedure on the real world, we choose the Taipei City as an empirical. So as you can see from the figure, the NTPU is my university campus located in New Taipei City. And around here, there are some very good examples we can investigate in depth. Especially it includes the smart living lab, the smart management, the creativity and the sharing, the disaster and the resilience consideration, and the creative and the smart sharing nodes. So we take this area as our empirical example. And this is analysis results. I will show it quickly. So we based on a future change rate of the indicators to show its importance, its relative importance for each of them. And then we can find, I'm sorry, some of the character from Chinese. So the B2 indicators is the mass transportation. And the empirical study and analysis, we utilized some objective steps to verify and to find the weights and to find the internal dependency. And finally, we can find their relative weighting. And why should we find the relative weighting? Because our resource is so limited. So we want to utilize our limited resource to the most important weights. So that is the purpose, is also the purpose of our research. Okay, and this is the study and analysis for our empirical. So the final results of the indicator valuation doesn't represent the necessity of the policy, but rather should be the highest priority in the future. So as you can see, the B2 indicator, the mass transportation, and C5, the popularization of science and technology are higher than others, which indicate that the policy scheme has a high priority attached to the future smart and sustainable city development.
Sorry to interrupt. Your time is actually over. Can you please wrap up your presentation and come quickly to a conclusion so that you do not steal time from the other presenters?
Okay, sure. Okay, no problem. So therefore, just 4 points of the conclusion. We present a systematic decision procedure to be used. And then based on our consideration of the resource limitations. And then the ranking demonstrated that transportation sustainability indicators are that satisfy the principles of a living city. And finally, our proposed the data-oriented DMP approach can be easily extended for other real-world urban environmental application. Okay, the end. Thank you for listening. Thank you.
Thank you very much, Wan Ming. Just a brief note to the audience. So if you have questions, please post them in the Q&A box, and I will then take them up later during the Q&A session. Now, I want quickly to lead over to the next presentation. We have Elaine Vasquez from the Federal University in Rio de Janeiro, and the presentation is titled Proposed Framework for Assessing the Priority Location of New Medium and High Capacity Transport Stations. Elaine, the floor is yours.
Okay, good morning. Nice to meet you, everyone. Thank you for the presentation, Christoph. I'm here to present a work based on a research group, and the research group includes 3 universities, the Federal University of Rio de Janeiro in Brazil, also the Federal Center of Technological Education also in Brazil, in Rio de Janeiro. And the last university is University in Australia, Sydney, the Faculty of Built Environment of New South Wales University. So the contents of the presentation, I will present the introduction of the paper, the objective, the novelty, the calculation method of indicators, PNT and population density, the application of the method to the city of Rio de Janeiro, some results and final considerations, and in the end, the main references. So in the introduction, I can tell you that the expansion of medium-sized cities in Brazil has increased a lot the decades of 80s and 90s. And this accelerated urbanization process were incentivized by the economic situation. And it happens a migration to more peripheral regions. And we have an urban expansion, an horizontal urban expansion. So this urban sprawl with a low density is the difficulties and the challenges for our urban mobility of the cities. Also, I brought here for you a nice view from Rio. You can see the Sugar Loaf and the Cristo Redentor, and also the location of the city of the Rio de Janeiro in our country. And our city, I live in Rio de Janeiro, we have a widespread urbanization model, and we have a spatial segregation, and we reinforced it with a low access to public transport services. So the objective, the novelty of the work, it's related with this situation. And the objective is to elaborate and apply a procedure that we can see choosing the priority location for planning of new medium and high ways of transport. And the novelty of the work, it's also the proposal for urban mobility, where transport planning evaluates the position of transport stations and terminals in order to understand how they can connect to existing urban occupation. So the method we propose to analyze and to measure the distance and the time traveling between the places of residence of the population of the cities and the transport stations. And we choose to make a procedure that we analyze two quantitative indicators. The first one is the people near transit, PNT, and the other one is the population density. So the PNT value is a percentage found by dividing the sum of all population values of the census tracts with 1 kilometer of the analyzed urban area, we call it POP 1 kilometer, by the total population value for each territory unit analyzed, POP total. Also the density represents the total number of inhabitants for a unit of land, its inhabitants per kilometer square. From the population density value of each analyzed location, it will be possible to understand which one we need to prioritize the location, which one we need to improve new transport stations. So we plot both indicators in a graphic, so like this one. And we have the average density value and PNT average value, and we divide in 4 quadrants. And this investigation should prioritize the development of new and medium high capacity structuring transport stations. We applied the method for the city of Rio de Janeiro. As I told you, we have problems of mobility, and we try to show this with the results. The city of Rio de Janeiro is a metropolitan region. We have an extensive road network, and we have historical problems of spatial valuation and a large number of public transport lines. We have the most important ones is the low, medium, and high capacities. In this work, we only use the data with medium and high capacity. So in this table, the table 2, we can see the modes of transports. And with medium and high capacity, we have the BRT and the VLT, and the same thing is the bus, né? But we have also train and we have also metro. The train in Rio de Janeiro, it's called Supervia. Also the map of the city, we can see in the second map in the right side, we have 106 neighborhoods. We have 33 administrative regions and 5 planning areas. And in the other figure, we can see the mapping of all these stations and their corridors. And with the results, we calculated the PNT and the population density for each of the 160 neighborhoods in the city, and some results, global results. We have 33 neighborhoods. They do not have any medium and high capacity structured transport stations, which means that PNT is 0%. And we have 23 neighborhoods with the PNT 100%, which means that we have medium and high capacity. It's a good structuring transport. Plotting all the data in the graphic. So we divide the graph in 4 quadrants, considering the average population density around 13,000 inhabitants per kilometer square, and the average neighborhood PNT around 49%. So I will show the analysis of the 4 quadrants. So the upper right quadrant, we can see that we have a high PNT and the area are extremely dense. It represents 46 districts, which means 29% of the city. And they are well-positioned stations in this quadrant. The upper left quadrant, we also have a high PNT, but we have a low population density. So this quadrant, we can increase maximize the use of these stations. And it represents around 22% of the city neighborhoods. The lower left quadrant, we have almost 23 neighborhoods, and it represents a low PNT and low density. So in this case, it represents, we have 7 neighborhoods between 0 and 10% DPNT, and low development of medium and high capacity could be a target. And our main result is the lower right quadrant. In the lower right quadrant, we have a low PNT, but we have areas with extremely dense territories. And we have few residents that have a good accessible distance from the stations. So the final considerations, we can see that the work presents a proposal to evaluate the priority location of medium and high capacity transport stations. We applied the proposal method in the city of Rio de Janeiro, and we could analyze the neighborhoods presented in the city and understand where it happens like the most terms of urban mobility. And also the works presented the location that we have the target to improve this urban mobility. So inserting new transport stations in the lower right quadrant, it will be a more efficient urban transport for the population of the city. So by the end, I present here the main reference of the work, and that's it. Thank you very much.
Thank you very much, Elaine, for this interesting presentation. So next up is the first Q&A session. So if there are no immediate questions, I would ask maybe one main way. So your presented study was very focused on Taipei. So could you think that maybe the same model can also be adapted to other cities?
Yes, exactly. Yeah, we adapt most of the criteria based on the EU. And as you may have heard about that, we always call it sustainable development, but now EU called it sustainable growth. That means the growth principles can replace the development criteria. So that means we don't need to really develop any economic related stuff, but we cannot help to ignore the growth. So there are 3 growth principles, including the sustainable growth, the smart growth, and the inclusive growth. So most of the criteria are based on the growth principles, and it can be applied not only in Western countries, but in Eastern countries. So especially if you have any chance to visit our university campus, you can find most of the principles are applied in our urban planning development process. So that's it. Thank you.
Thank you. Yeah, there's still no questions in the Q&A box. So therefore I would ask Elaine, so the model you have presented, it beautifully shows where actually is a lack of mass transportation or medium and high capacity transport station. So my question would be, so have you thought about it if it's also feasible to maybe include like factors like, so I'm thinking of that maybe like existing infrastructure or the settlement structure is maybe guiding how further or new stations can be built. So have you thought about also to implement such limiting factors in your calculation?
We didn't thought about it, but it's a good question. I think I will improve it with my students.
Okay. Thank you very much. So are there any other questions? So to the audience, please just type them into the Q&A box. If not, then thank you very much for our first two speakers for their presentations. And then I suggest that we move on with the next presentation. This presentation is by Damiana Chinese from the University of Udine. The title of the presentation is Prospects for Alternative Powertrains for Road Freight Transport in Italy based on a probabilistic TCO model. So Damiana, the floor is yours.
Okay, then thanks everybody. Our work, as anticipated, deals with the costs of alternative powertrains for road freight transport in Italy. And what we are developing here is basically a cost model and a cost-benefit ratio analysis. Well, so, road freight transport is the most popular transport mode for freight in Italy. It accounts for about 60% of the ton kilometers transported in Italy, and for about 6% of the total national carbon equivalent emission, according to our environmental agency. Italy is also representing about 6% of road freight transport volumes in Italy, in Europe, in terms of Italian companies in charge of transport. And those companies have been interviewed in recent surveys, and the most frequent barrier to investing in green technologies is the lack of internal financial resources. They are much in need of external incentives, and the current emergency and consequent economic crisis may have worsened this situation, while on the other hand, there is much debate about incentives which can be started to overcome the current situation, so to restart economy, whether and how to give incentives to freight transport companies. Our study goes in this direction, so in the direction of examining the costs and seeing whether and where it is necessary to give incentives. The approach is based on the total cost of ownership, which is a financial indicator which takes into account the capital costs of vehicles and the operational cost of vehicles, opportunely weighted with capitalization factors, so present values. It accounts for resale values, it accounts for fuel, maintenance, tires, and operation costs. And it is referred, as in previous literature, which deals with cars in that case, to the kilometers traveled. So we divide it by the annual kilometers traveled. Our model is probabilistic in that we introduce probability distributions based on previous literature for cars here, and on own elaborations on specific data for freight transport vehicles, in particular as to the annual mileage, so the kilometers traveled. Some of the variables are still non-stochastic in nature. We obtain a Monte Carlo simulation approach, so we repeat the simulation 10,000 times and obtain a probability distribution for this output. So the probability of having a certain TCO. The carbon emission have been estimated with a well-to-wheel approach with a GRC methodology. And the powertrains we considered were battery equivalent battery electric vehicles, compressed natural gas, liquefied natural gas, and as a traditional powertrain, the diesel Euro 6, which was simulated with their software covered. These are actually the general powertrains, depending on size class of the vehicles, we take a reference vehicle for each class: light duty, medium duty, and heavy duty vehicles. And electric battery vehicles have been considered only as alternative to light duty vehicles. For medium duty vehicles, we consider compressed natural gas as an alternative, heavy duty liquefied natural gas, which is starting to spread in Italy. We wanted to make some scenario analysis accounting for this difference in the economic situation. So we consider the change in fuel prices consequent to the lockdown in Italy, but also the expected reduction in the national freight transport due to the reduction in the gross domestic product as a result of economic crisis. We found through a literature research, through useful model, making this link, and use the Italian data to develop those models. And this is the equation for the more pessimistic model, which estimates a reduction of national total freight about 32% for a expected gross domestic product reduction of 9%. So you'll see here we will develop scenarios for just fuel reduction price, freight reduction less pessimistic, and the most pessimistic, this one is F km2, reduction of fuel freight. So the first thing is the carbon emission assessment for the alternatives, and you see that they are all beneficial to this respect. So in all cases, we will have this difference, this reduction in emissions per kilometer, switching from alternative to new powertrain. Here you see the results for the TCO per kilometer. This is for light duty vehicles. First thing you see that you need incentives, that battery electric vehicles are more costly than diesel alternatives, traditional vehicles, while compressed natural gas vehicles are almost competitive, but still slightly more expensive than the traditional one. The low mileage situation worsen this difference. So it makes alternative powertrains even less competitive, in that we assume that if goods travel less, then individual vehicles will travel less. And so lower mileage will result in higher operational, higher fixed costs and less competitive TCO. This is not always true for medium duty vehicles. In this case, CNG, the alternative powertrain, is slightly better than diesel. So these are the expected values of the TCO. And so in this case, no incentives would be needed with the existing mileage, but also with the reduced mileage after economic crisis. Here you see the results for the heavy duty vehicles. For heavy duty vehicles, incentives would be needed in that liquefied natural gas, which gives some benefits, is anyway more costly. And the difference is worse if the mileage is reduced as a consequence of economic crisis. But the difference is not as bad as for light duty vehicles. Okay, so worst case, low duty vehicles, no incentives, medium duty vehicles, incentives needed for heavy duty vehicles. The last thing we did, last result, is to make the ratio between the additional costs of alternative powertrains and the carbon emission reduction. So additional cost divided by reduction of CO2 emission. What we get is the cost of reducing CO2 emission, which you have here in the y-axis. And here you see, this is the scenario, let's say, before crisis, with just a reduction in fuel prices. Here is the scenario after crisis with small reduction in the travel kilometer, in the mileage, and this is the worst case scenario. What you see here is that natural gas has anyway the lowest costs, which are very high compared with other sectors, with carbon prices in other sectors, but in line with literature, and a relatively small reduction in freight, national freight transport wouldn't alter the things much. While for battery electric vehicles, we are more in the order of 600 euro per equivalent ton of CO2 emission saved. For light duty vehicles, we have also the highest uncertainty anyway, in case we have a strong reduction in the traveling volumes. To conclude, the probabilistic model is useful to capture the uncertainty of this situation. Anyway, we have no crystal ball. Many things are questionable, and we are aware that ours are scenarios. Also, we have used a single methodology to assess well-to-wheel emissions. We would like to improve our work by incorporating other factors, such as, for instance, the impact of batteries in the life cycle, which wasn't used by the GRC methodology. We have found out, as we have shown, the annual kilometers travel is a key critical parameter and would be have to be recorded and investigated to understand how will the road freight logistic market develop in Italy, at least under those changed planetary conditions. Because we have assumed that mileage would be changed homogeneously for everybody, kind of balkanization scenario where everybody will work less and everybody will keep small. But it may be that simply older or smaller firms will be set out of the market and there will be concentration, and maybe those will keep on having the same mileage and the same costs as before, more or less. Also, we will be interested in monitoring the way that fuel and power prices will develop, in that we had only the data for 4 months as at the time of the study, and see whether new time series will change the situation much. And yes, that's more or less everything. We would also like to work at the fleet level, so to consider from these individual results, the results for the whole Italian fleet, or at least for Northern Italy. So thank you for your attention. I'm open to questions. And yes, I'm more or less physically here. And here is the address where you can reach me. Thank you.
Okay. Thank you very much, Damiana. So to the audience, please, if you have a question, type them into the Q&A box. And I do not want to lose more time and would directly introduce Victoria Mangarowska from the International Balkan University with a presentation titled Sustainable Development Plan of Transport and Mobility in the City of Skopje. So, Victoria,
thank you very much. Yes. Okay, first of all, I want to congratulate the organizers of the World Sustainability Forum, that they managed to put together so many researchers and professors around the world. And I will start with my presentation. So it is Sustainable Development Plan of Transport Mobility in the City of Skopje. So first of all, it is about the cities that by 2030, it is estimated that 60% of the global population is projected to be urban. So cities are drivers of global warming, climate change, and they concentrate populations, build environment, industries, economical activities that are emitters of CO2 and green gas emissions. They also become hotspots of vulnerability to the climate change impacts, such as flooding, climate and weather hazards. Then the Sustainable Development Goals, it is transforming 17 goals, which are from the United Nations for transforming our world, the 2030 Agenda for Sustainable Development. And here we will focus about Sustainable Development Goal 11, such as making sustainable cities and communities. And some of these also remarks from the Sustainable Development Goal 11, it is safe and affordable housing, safe, affordable, accessible and sustainable transport system, integrated sustainable urbanization, protect cultural and natural heritage, protect the poor people in vulnerable situations, reduce the environmental impact of the safe, inclusive and accessible green public space. For Sustainable Development Goals, we can see overall performance also for each country. So for Macedonia, also the overall performance, it is 57. We can see for each goal as well from the data from SDG Index org, and we can see some improvement that has been done, especially for improved water source in piped water source for the population drinking water. Urban climate change scenarios for Macedonia, we can see that there is a strategy for sustainable development in Republic of Macedonia, which includes the energy supply for low carbon technologies, transport, low carbon technologies, building as well, moving towards passive house standard buildings and also renewable energies, energy demand, and also low carbon cities, public transportation and cycling. The scenarios show that also green gas emission scenario in Macedonia, it is that from, it will increase from 9,000 kiloton from 2012 to 18,340 kiloton in 2035. Another also scenario about the final energy consumption scenarios are that it will be highest growth in the transport sector and also followed by commercial, service sector, industry, and also residential sector. Transport system in the city of Skopje, we can see that the city of Skopje has grown the capital city that is has grown 4 times over the last 60 years. In 2020, there is a population, estimated populations of 800,926 inhabitants in the city of Skopje. And Skopje also consists of 10 administrative municipalities and has fast development over the past few years. We can see that the city road traffic network in Skopje consists of 211 kilometers of primary and secondary transportation roads, and also the public transport system and the modal system consist of cars, public transport with buses, bicycles, electrical scooters, walking, motorbikes, electromobiles, and also official transportations. Here we can see also the spatial development of the city of Skopje, the urbanistic plans. So we can see that we have a longitudinal axis, how also the city developed over the years. And also in the city center, we have a radial organization where the roads practically lead to the city square. The way how the city developed over the years, so from the urbanistic plan of 2012 until 2012, we can see that it increased actually by 4 times with this longitudinal organization. Another also interesting aspect for the city of Skopje is that we have strategy moving towards sustainable development in the public transport in the city of Skopje. It should focus in the economical and also sociological aspect as well. So we have urban environmental sustainability to minimize pollution and also the energy efficient concepts, economical sustainability to have efficient economical transport, social sustainability to have social integrated city, and contribution to livable city such as urban transport system city for people and not for vehicles. What is characteristic also about the transport system in the city of Skopje is that we can see also the medians. These are actually here in the boulevard of the city of Skopje. They have developed green spaces, which also have protection, prevention from the people walking also on the street, but also it brings more green space and green areas into the city. We can see also here aerial view of the Skopje city fortress, where actually we can see the transportation system, and also we can see the green spaces in its surrounding. Another also concept that the city is moving towards, it is the connection of the sustainable traffic system connected with landscape architecture. So the concept is to minimize the amount of vehicular circulation, preserve natural features, and create street that complements the natural topography. Create design for natural drainage, provide natural streetscape, minimize road pavement, provide adequate pedestrian connections, and incorporate multimodal travel and bicycle lanes. We can see also the other models that are improving in the city of Skopje. So we can see electromobility, that electrical cars that also are from the municipality and the city of Skopje owned. And also we can see a trend that is increasing the electrical scooters in Skopje. Another system is also the public transportation, that is with buses, double-decker buses, and also electrical charged buses. And we can see also the sustainable action plan in the city of Skopje, which had been developed from 2015, and also it is ongoing with improvement of 50 kilometers bicycle lanes in the city of Skopje. So the main action plan of the bicycle travel and infrastructure system is to increase the bicycle traffic in the relation of 2021 by 5%, increase the long-term usage of bicycle infrastructure network by 50% by 2021, reduce the number of traffic accidents, and reduce the CO2 emissions. We can see also the bicycle lanes in Skopje, the development over the past few years, which nowadays, particularly, they're increased into the mobility and transport in Skopje. And this is actually here the sports centers and recreation zones next to River Vardar, where most of the people also recreate and go with bikes. Another thing is also boulevard relocation of bicycle lanes, where elastic pillars have been replaced, and also the boulevard roads areas have been replaced from 3.5 meters to 3 meters to provide space for a bicycle lane of 1.5 meter. The movement of also cycling in the city of Skopje had increased, so we can see the development of the network for bicycles that have been improved in many of the streets. And also we can see that the sustainable urban mobility development, there is a difference between the traditional transport planning and also sustainable urban planning. The traditional transport planning focuses on the traffic, on the implementation with transport engineers, with infrastructure is the main aspect, also investment guided planning. And the sustainable urban mobility plan focuses on the people, implemented by interdisciplinary planning approach, combination of infrastructure, information, then also accessibility and quality of life, and cost-effective achievement of sustainable goals. So the one aspect is, if you plan cities for cars and traffic, you will get a city with cars and traffic, and if you plan city for people and places, you will get city with people and places. And in the end, also as a conclusion, is that the urban mobility goes for the sustainable development in the city of Skopje. It is creating also a sustainable development plan for adaptation and mitigation planning, which demand clear strategy to identify the urban mobility goals for sustainable development in Skopje, reduction of car use and improvement of sustainable public transport, infrastructure and investment in bicycle facilities, improvement system for walking environment, smart city and livable city with technological innovations and demand services and cycling, improving of public transport and also sustainable transport that will reduce the air pollution. Thank you very much for your attention.
Thank you, Victoria. So we have lost some time due to technical reasons. Therefore, I want now introduce Longbin Xu from the Nanjing Tech University and the presentation titled Built Environment of Settlements and Carbon Emissions of Households Travel, a case study in the central area of Nanjing City. So Longbin, the floor is yours.
Thank you, Christoph. Good morning, everyone. Ms. Xiang and I come from Nanjing Tech University. We will give the presentation about the built environment settlement of settlements and carbon emission of household travel. It's a case study in the central area of Nanjing City. This research is carried out in the context of comprehensive upgrading of urban settlements in the inner cities of China. We try to study the impact of built environment factors on the carbon emission from household travel, and we then propose low carbon strategies for the upgrading of urban settlements. Hongyan, Ms. Xiang, we'll talk about it in details. She's a key member of the research. Hongyan?
Okay. Good morning, ladies and gentlemen. I'm honored to have this chance to speak at this conference. I'll start from the background of our study. After rapid urbanization, the inner city upgrading will be a focus of future urban construction in China. According to a guideline issued in this July by the State Council of China, 39,000 old urban settlements with 7 million households will be upgraded in this year alone. However, in many cases, upgrading projects lack green and no carbon concepts and know-how. As households' daily travel is one of the key sources of urban carbon emission, how to reduce the emission while improving transportation conditions during the upgrading is an urgent issue faced by planning professionals and decision makers. Our research is to examine the impact of built environment factors of old settlements on travel carbon emission in the central area of Nanjing, China, and then we suggest no carbon strategies. About the method, we collected household travel data by field survey. We made correlation analysis with SPSS between the built environment variables and the carbon emission of household travel. We then made regression analysis. Carbon emission from household travel are dependent variables, and built environment factors are independent variables. We collected the built environment data from relevant websites, Google Earth, land use maps, GIS data. The field survey was made in 9 segments in Nanjing. We sent out questionnaires, made interviews with the residents and the management to collect carbon emission related data. Under density, diversity, destination accessibility, and design, we defined these 10 key built environment factors. About area of settlements, floor area ratio, building density, degree of land use mixing, distance to business center, accessibility to public facility, to bus, to metro, intersection density, road network equilibrium. Then the carbon emission was calculated based on IPCC guidelines. The emission is mainly determined by the distance and the coefficients of different travel modes. We analyzed the mixing degrees of 5 different types of land use within the radius of 1 kilometer. 5 types of land use include administration and public service, commercial and business facilities, residential, road, street and transportation, green space, and school. We use GIS data to analyze the 4-way intersection and 3-way intersection within the radius of 1 km to calculate the intersection density. Quantitative analysis of carbon emission show walking and bicycle are the most common travel modes, followed by electric bicycle. Private cars are the main source of carbon emission, according for 88.9%, although it only makes up 17.5% of the total travel. 60% of carbon emission are released by 18% of households, which is close to principle of 60-20. These scatter plots show the correlation between the built environmental variables and the carbon emission of household travel. The positive correlated factors are area of settlements and distance to business center. The negative correlated factors are building density, light mixing degree, accessibility to public facility, accessibility to metro, and the intersection density. But the factor of floor area ratio, accessibility to bus, road network equilibrium show no correlation. This table shows the strength of correlation of different variables to the carbon emission. Land use mixing degree, accessibility to public facility, and the intersection density have strong linear correlation. Settlement area, building density, distance to business center, and accessibility to metro have weak linear correlation. We then made a regression analysis and built a simple linear regression model to quantify the correlation. For example, for each RD unit increase, the carbon emission of household travel may be reduced by 8.37% kilogram per year. Now, the major findings are walking, bicycle, and electric bicycle are the main means of daily travel. However, most of carbon emission is from car travel. The higher the building density, which means less parking space, the lower carbon emission of household travel. The higher the land use mixing degree, and the more complete the public facility, then the lower the carbon emission from travels to meet the daily needs. Accessibility to metro affects the carbon emission of residents' long-distance travel. The intersection density has a strong impact on travel carbon emission. The higher the intersection density, the lower the travel carbon emission, because it would be easier for residents to reach bus stops or service facility by the walking and cycling. And now, therefore, we make recommendations to integrate low carbon strategies into the upgrading of old settlements. The settlements with smaller area and higher intersection density have lower carbon emission. So we suggest to open large-scale gated settlements and improve the road system. We suggest improving the diversity of land use and the accessibility to public service facilities in the upgrading. It can reduce the carbon emission of residents' travel for daily work and living. To improve the accessibility to metro, we suggest to set up safe and convenient parking space for bicycle and electric bicycles, both at a subway station and a residential area. In the old location of limited space in the older settlements, we suggest first improve public space, ensuring safer and more comfortable walking and bicycle space rather than providing more parking space. A few households generate most of travel carbon emission, so it leads to guide resident participation, cultivate no carbon awareness, and encourage walking and bicycle travel. That is all my presentation. Thank you for your attention.
Thank you very much to all the three speakers. All of your presentations were very, very interesting and of course policy relevant. If I'm looking on the Q&A box, I've seen that Damiano already has answered the question written. So to the audience again, please, if you have questions, write them into the Q&A box. Victoria. So in your presentation, you have shown a lot of different measures regarding a better sustainability of transport and mobility in Skopje. So there are a lot of measures. So maybe if I can ask you, in your opinion, which of these measures for the future would be the one with the highest priority?
Okay, there, as you said, a lot of measures now being taken into account in Skopje. One of the priority, because I'm teaching also in the Faculty of Architecture, I can see also architecture, energy efficiency in the city of Skopje. Transportation, to have, you know, more electrical cars and also more renewable energy definitely is one of the things. Also, I had one question about metro station, implementing of metro station in the city of Skopje, but it had earthquake in 1963. So there should be precautions because of that for the metro station, but tram station is definitely because of the increasement of the city of Skopje. Nowadays, tram station should be implemented, and because we're dealing also with a lot of air pollution, that should be one of the priorities, I think. And also heating systems, heating to be more centralized and more efficient. I think those are three priorities. There are also other things. Cycling nowadays, we can see particularly also that, especially with COVID situation, many people are using cycling. The infrastructure of the city changed, so that is also one of the things that, and electromobility is one of the things that is improving in the city of Skopje. Thank you for your question.
And then maybe I just received the question directly in the chat for Longbin and Hongyan. So the attendee is asking, so did I understand correctly that the main need for action is to make certain households aware of their mobility behavior to improve the carbon footprint of these settlements? So did he or she understand correctly that this is like the main need for action to change the mobility behavior of the inhabitants of the settlements?
Yeah, this part of the recommendations. Because we are in China, we have a really big plan to upgrade the youth settlements, mainly from the government. So we provide recommendations to change the upgrading strategies. In one way, yeah, we want to, for example, to open the gated earth settlements, or we build more road for the people, not for the cars. And the other sides, we want to also to change the mobility behavior, because walk and cycling bicycling is more ecological, more low carbon. That's our suggestions. Yeah, in two ways. Yeah.
Okay, thank you very much. And maybe just one last question to Damiana. And so, as it was already stated in the question, you answered directly in the Q&A box. And so, like the results of your study, they're very relevant also to government. So, have you already shared these results with external stakeholders outside of the scientific community, like government, public administration?
No, because they are very preliminary, and we need to further elaborate on that. But it's our intention, of course. Yes. Thank you.
Okay. Okay. Thank you very much. So then I think this was it for this session. And thank you very much to all the speakers. They were all very interesting presentations. And then is now a break until 12:10, and we will start then with the next session on understanding impacts. Thank you very much.